Good afternoon and welcome to Webinar Wednesday in this, our 9th year of offering up-to-date and informative webinars to the HTM industry. Today we are joined by Julio Castro, Regional Sales Director of Pronk Technologies. Webinar Wednesday would like to thank our sponsor, Pronk Technologies. Pronk Technologies' mission is to provide innovative products to refine and streamline the biomedical maintenance and support process. Biomeds in the field need equipment that is portable, affordable, reliable, and easy to use. Pronk designs and manufactures specialized diagnostic tools that are tailored to their needs. Pronk's innovative designs have been granted 17 patents worldwide. For more information, please visit pronktech.com. Just a reminder that TechNation is headed to our Spring MD Expo at the Woodlands Waterway Marriott Hotel and Convention Center in Houston, Texas, from April the 11th to the 13th. Please join us for 3 days of education, networking, and the latest advances in medical technology products and services. Registration is open, so for more details, please visit mdexposhow.com. Today's webinar is eligible for 1 CE credit from the ACI, and you can obtain your CE certificate by completing the post-webinar survey, which will be emailed 1 hour after the completion of today's webinar. You must complete the survey to receive your 1 CE credit, and you'll be able to download the certificate directly from your computer once the survey is submitted. If you have any questions, you can reach us at webinar@mdpublishing.com. Okay, let's kick off today's webinar by giving away one of our Webinar Wednesday t-shirts to the attendee that can tell me the answer to the following trivia question. Which state is hosting the Super Bowl on Sunday? Answer now using the questions feature on your dashboard, and I'll reveal the answer at the end of the webinar. We'll wrap up today's presentation with a live Q&A, so please submit any questions anytime using the questions feature on the webinar dashboard. As I mentioned earlier, our presenter today is Julio Castro, and he will be discussing defib maintenance, completing manufacturer-based PMs faster than ever before. Julio, you may begin whenever you're ready.
Thank you very much, Linda. Good morning, good afternoon, everyone. Thanks again for attending Webinar Wednesday. We appreciate you taking the time out of your busy schedule to attend the presentation. We're going to be talking about these important devices and covering a wide range of topics today, including being able to do the service on these important devices. And we're going to cover how to make sure that we're following everything we need to do to service these defibrillators, the importance of servicing them, being able to find how to find failure and incident information regarding these devices that are available to us, common issues that are reported to the FDA, things we want to point out that are common issues that come up, and things that we could be aware of when we're servicing these devices. Key points to consider beyond the FDA when we're servicing defibrillators that I think will be important to cover. And we're also going to have an actual demonstration of performing a defib, a PM on a defibrillator, following the manufacturer's procedure, highlighting just some of the key things to be aware of and how to perform these key tests when we're doing the service on defibrillators. So let's get started. Servicing defibrillators, of course, is a very key focus in healthcare. These are life support devices that play a critical role in healthcare, so it's important that we service these to the best of our ability. These devices can be really high wear and tear devices, depending on their use. Of course, they're used throughout healthcare, in particularly in the emergency care and field use situations. These devices can be subject to a lot of physical handling that can cause some functions to really wear out or be damaged because of the use in emergency care and field situations. So it's really important that we follow the manufacturer's procedures and the service intervals as our minimum standard of service. So there's a lot of features within these devices. It's important that we understand what should we be testing when we're servicing them. And so the manufacturer's procedures actually are really detailed and helpful to understand, okay, what are the things that are important here? The service intervals, of course, are important too. Manufacturers will list in their service manuals what are the PM intervals or the service intervals for these devices, be it the device, be it maybe the batteries themselves. It's important we follow those as a minimum standard. And depending on our facility, depending on the application, you may want to consider even servicing them more frequently. based maybe on service history. You may want to do them more frequently based on wear and tear. And generally speaking, a lot of organizations actually service the defibrillators once every 6 months due to their high use model, the wear and tear that can impact their performance. So it's important that we really specify a good standard of service intervals so that we're confident these devices will work when we need them to. Just as important as doing the service, we want to make sure we document all of the service we did. For our own organization's standpoint, to make sure that we have our documentation there of everything we service, everything past the manufacturer's performance. So if there's any issues we observed, that we make sure we capture those in our service report so we can tightly manage the history of the service that we just performed on these defibrillators. It's important to also be aware of manufacturer notifications. These could be done by direct notifications to users. Manufacturers post these things on their website. The FDA has a website. They also post these things. And so it's important to keep our ear to the ground, so to speak, and be aware of anything that has come through that can impact the performance of the device that needs to be updated. Could be a software update, could be a field notification, something needs to be updated or replaced. So it's important we're aware of these things. Also, as part of our service and maintenance, or even when you receive a service call regarding some performance issues on the devices, it's really important to take advantage of the event logs that the defibrillator has. The devices have an event log where they capture any errors that occur on the defibrillators into their event log. It's generally found in the service section of the defibrillator itself, and you can glean really good information from time to time on any errors that have been happening. If the nurse reports something, maybe you're not able to see it right away, check the event logs. Or if you're going to do a preventative maintenance, before you even get started, check the event logs, see if there's been any continuous errors that have been happening, any errors that could impact performance, something that could really help us and make sure that we're servicing these devices the best we can. A resource that's available to all of us that I think is really important, I wanted to share with you, is something that's an FDA website that's referred to as the MAUD database. It's the Manufacturer and User Facility Device Experience Database. Nice fancy name for a really important database that is available to all of us to search. And it's a database where the FDA maintains information records of any regulated device or 510K device that they have to approve onto the marketplace. So in this database, I have the ability to search any kind of FDA regulated device, including defibrillators, and search for information by all these different fields. So if you're wanting to get informed of maybe a particular issue on a particular brand device, you can search for that device in this database. Maybe you're wanting to understand if other facilities are having similar issues to what you're having, or you want to be informed of any particular problems or any issues reported to the FDA regarding a medical device, any medical device, you can search this database and find it. So it can be really useful. The website link is here at the bottom, so it's available. You could utilize it to search for any information on this website. One example here, just to kind of give you a brief overview of what the page would look like. This is kind of an example of report. We kind of took away manufacturers' names, not wanting to highlight any particular manufacturer. All medical devices, have issues reported to the FDA, so it's not unusual that it happens. It's a centrally located database that allows us to share information and to be able to have a good vision into what could be happening in the field with these devices. So here you have a defibrillator. You can see it here. At the top, below that, you'll have information like the model number, what kind of problem did it have. You can see this one in particular has a device failure. It's a self-test failed. And it will give you information about, well, was there a patient related to this incident that was reported, or this report that was made? What kind of event was it? This was a malfunction. And then the manufacturer actually is required to investigate and determine what could have happened with any and all of these reports submitted for the FDA. So it can be a really good tool for the manufacturer, for the end users. You can see what issues have been reported, and the manufacturer has to respond and investigate any of these issues that are reported. So in this particular case, you can see the manufacturer added to this open issue here that it hasn't received the device yet for evaluation. So it's still being under investigation. And what's also helpful is under event description, it will kind of give you an overview of what was the issue. And in this particular case, you could see here that the biomed was doing some testing and it failed to self-test for the defib. They also indicated there was no patient involved, but they felt it was important to report it to the FDA, and they did such. And so it gives you really good information below that. I don't have it here on the screen, but you'll be able to see additional information about the brand, the device type, serial number, all those sorts of things, and all of the details regarding that investigation that's taking place. So it's a really good database. Definitely want to take advantage of utilizing that to help us gain some information about servicing any kind of medical device. So I did a little research and pulled together some common reports or common issues that were reported to the FDA regarding defibrillators. And I wanted to share this with you because it can help us when we service these devices. Some of the common issues that were reported are the display was blanking during use or when it powered up. So literally the display would not come on. That was reported numerous times. And when we did this research for the presentation, we only looked back about a year's worth of time. So this is fairly recent. The device was powering off unexpectedly. So someone's trying to use the defibrillator and it just powers off. You have pacer energy not being delivered when they expected it. So they programmed the defibrillator, but the pacer energy was not delivered. The unit intermittently would power off. This was one specific case we noticed. I wanted to add it here because it was intermittently powering off in clinical use, and the manufacturer did investigate it, did post it on the FDA website, and they found that the battery was not being seated properly in the device. So seems like a simple but important thing to take note of, and so it's important that understand that sometimes it may not be as complex of an issue as you would think. In this case, critical but important that a failure that occurred, the battery was not seated properly. Had other issues reported where the battery pins on the defibrillator or the battery itself were damaged in a way where it was causing intermittent operation on battery power. So imagine that you're talking about somewhat of an accessory. It is integral, but it's an external component. And if those battery pins are damaged in a certain way, it can cause the device to power off when you need it, particularly in the field where you're commonly using it on batteries. Did not defibrillate on a patient. So trying to use it on a patient, it went to defib and it did not discharge. A number of reports along those lines. And another one I thought was pertinent was the shock button would work intermittently. It wouldn't, you press the shock button and it wouldn't always deliver the energy. Simple thing, a button, but it goes back to emphasizing the importance of how all of these key things on a defibrillator are important to test and service and inspect. Because in the field, any of these situations, any of these features or parameters don't function properly, it can lead to a patient incident or problems in taking care of a patient. So it's important that we kind of keep these examples in mind when we're out there servicing defibrillators. Of course, when we're servicing defibrillators, we need to make sure we have all the proper tools, basic tools, the defibrillator pacer analyzer we need to have, electrical safety analyzer. If the defibrillator has vital signs parameters, we'll need a patient simulator, calibrated stopwatch, and we need access to the service manual, the maintenance procedures. These are very, very critical. The service procedures are, of course, in the service manual. They're very detailed. They can be very extensive, but they do contain a lot of key steps that the manufacturer puts in there. And sometimes we think, oh, well, the manufacturer's making it longer than it needs to. But a lot of these things, particularly on defibrillators, are important things. And the manuals are written in such a way where the manufacturer is trying to account for the wear and tear, the things that can go wrong with the device, and wanting to give us as technicians that information so we're looking out for these things when we're doing the service. So having that service maintenance procedure, that PM procedure, is really critical. Not only the procedure, but of course also knowing what are the pass-fail tolerances. We also want to make sure we document all these results. As we mentioned, we want to keep track of these critical devices and everything we did so that we're confident we completed all the steps and we have that confidence that this device is really ready to go back onto the clinical floor to be used on patients. There are some manufacturer-specific fixtures and test equipment that they require that are brand specific. So you'll see them in the service manual. Not all brands have the same fixturing. Some are specific to brands. One particular brand wants you to utilize a kind of proprietary battery current tester to test the battery charging circuit. And so you'll have to make sure you look at these service manuals for some of these details on specific fixturing you also need to have on hand when doing the service. So in terms of doing the defibrillator, of course, this really applies for all medical devices, but for defibrillators, it's even more critical is the visual inspections. You want to make sure you're always doing good visual inspections on the units. It's specified numerous times in the service manual itself. Physical damage is something that we really need to pay particular attention to. You may see some physical damage on the exterior part of the unit, but it also could lead to probable problems performance-wise. So any physical damage is a good indicator that you may need to look at this more thoroughly because it could impact performance of the device. The cabling. Cabling is a common issue that can come up in failures. It's important that we always check the cabling, be it the ECG cable, SPO2, the multifunction or the quick combo cable as they refer to it for the defib pads. All of these things should be thoroughly checked, including the connectors on the accessories, connectors on the medical devices. Anything that can cause an intermittent connection can be really problematic because in one moment it could work and maybe the next moment when someone is moving cabling around, the unit around, it may stop functioning as you would expect. So it's always like to emphasize that it's important that we do a wiggle test or the cable wiggle test, making sure you're trying to verify that under no circumstances do you lose communication, do you lose the performance of that particular cable, regardless of how you orient the cable. And so can't emphasize enough the importance of doing the cable testing, particularly on defibrillators. Battery compartment, as we mentioned earlier, you saw issues reported to the FDA about battery compartment issues. Always check that battery compartment. I know we need to check the battery for battery life and battery performance, but always check the electrical connections between the battery. And if the battery utilizes a latch to make that electrical contact to the defibrillator, check that latch, check the fit, check for any loose kind of connectivity of that battery compartment or connectors so that we assure that we don't have any intermittent performance out in the field. One of the important features that we need to test as part of the PM or even a repair or investigate performance-wise if some incident is reported to us are the discharge tests, the shock test. And so it's important to understand that when we're doing shock testing, that the patient plays an important role in how that energy is delivered to it. And so there's a patient impedance involved it becomes integral into the circuit, so to speak, when we're shocking the patient. And it's referred to as the patient impedance or the transthoracic impedance, the TTI value, and it varies from person to person. And it's a resistance, it's kind of a resistance that naturally occurs between 2 points. So of course, for defibrillators, you're attaching the paddles or you're attaching the disposable pads to the patient, and it has a resistance between the 2 points. And this resistance varies, and that's what they refer to as a TTI value. It varies depending on the person's age, their skin condition, their body weight, their body mass index, their BMI, how much hair is on the patient, oils, etc. So these things cause that impedance to be different depending on the person. And so this can impact how the defibrillator delivers its energy. Of course, the defibrillator is delivering the energy in joules, which is generally the general basic formula is it's a time, how much energy is being delivered over what time, multiplied by the voltage, multiplied by the current being applied. So of course, the voltage is calculated by the resistance or the impedance of the person times the current being discharged. And so depending on that person's impedance, that voltage will vary, which varies the energy delivered to the patient. So it's important to understand that principle because it could impact the defibrillator's performance. And so we need to be aware of that. Manufacturers of defibrillators have an international standard they have to test to when they're designing their devices, and they submit their information to the FDA saying, look, we've done this testing, we've confirmed that the defibrillator will discharge within its specified tolerances across various common impedances of a patient. So the standard calls out for the manufacturers to test from low impedances down from 25 ohms all the way up to 175 ohms is the standard. And the manufacturer's got to do this to make sure that the defib under all those various conditions can discharge within tolerance. So when we're servicing these devices, it's important that we kind of have that in the back of our minds and that we make sure we verify what is the impedance resistance or the impedance load that the manufacturer wants me to do the service of this defibrillator. The most common impedance is 50 ohms. Most all analyzers, defibrillator analyzers, have an impedance set for 50 ohms, and that's designed for PMs, and that's generally the standard. But if you're servicing a device and maybe there's a question about how it performs energy-wise, energy delivered, or maybe you've done a repair on the defibrillator and you've actually done some repair to the circuit that affects or dictates the energy being discharged, it is important to consider testing across different impedances. And so most all defibrillator analyzers have an option. It's an external variable load module that you can purchase that allows you to do discharge testing by varying the impedance to simulate the different TTI levels that can be simulated in a patient. And you can find in the service manuals on some of the defibrillators, they will specify, depending on the load impedance you set your defibrillator analyzer to, you could see various output readings. It won't always be exactly the same because the impedance of the patient is varying. But it will specify that the readings should all be within the specified tolerance of the defibrillator, but it will not always be exactly the same reading. So if you're doing a discharge test at 100 joules at 25 ohm load, you may have a particular value delivered. But if you're doing it at 175 ohms, you could very well see that the defibrillator shock output could be a little different. It should still be within spec, but it could be different. But this could be a good tool for us to be able to verify that the defibrillator does work properly across all wide ranges so that we'll have that much more confidence that it does meet its specifications. So not necessarily needs to be done for PM, but it could be a good best practice to utilize, particularly if you're investigating an issue reported by the clinicians, or if you're actually doing repairs to the defibrillator. Pacing is, of course, another option defibrillators have. Transcutaneous pacing or external pacing is utilized as a temporary means to control the heart rate by delivering controlled pulses between pacer pads and the leads connected to the patient. And so this is about running current through the pads, from the defibrillator through the pads across the heart, trying to get the heart contract to control the heart rate. So this is a current delivery feature that allows us to kind of capture the heart by pushing current through the chest across the heart. Generally starts at around 10 milliamps to try to capture a heart, but the patient could require much higher current to do this test. And so that's why we need to make sure that we've test at various current levels so that we're sure that defibrillator captures across wide ranges, because it may not always be done at a particular set current. So testing at various currents can be very helpful. Defibrillators have fixed or demand pacing modes where you can set, do you want to always have current running through the heart at a fixed current value, or you want to do it on demand if the heart rate drops below a certain value, do you want to go ahead and pace at that point? And of course, the user can also control the pulse rate, so to speak, the pulses per minute, which will dictate the heart rate on the patient. So demand mode only paces when the heart rate is out of the program range. That can be used in the field on patients. Fixed can also be utilized, as I mentioned, and fixed is what we utilize when we're doing service on the units, when we're doing the PMs. So performing pacer testing, we want to make sure we're doing it according to the manufacturer's requirements. They also have test load impedance requirements for pacer testing. It may not always be the same impedance, so always be sure to check the service manual to see what impedance does the manufacturer want me to test the pacer current testing, the pacing testing for that particular device. So make sure you check that. Always important to do at the various pacer currents specified in the service manual, or you may want to consider that as a best practice, even if it doesn't specify that, just to make sure it works across a wide range, including the pulses per minute as well. So getting ready to do the service on this defibrillator, we're going to be utilizing our test equipment along with some advances that have come on the marketplace that allow us to be able to utilize it with our smart device to be able to run the manufacturer's procedure. So this is a platform that we've developed called Pronk Mobilize. It allows us to wirelessly control the test equipment to a mobile device, run the procedure, and do the PM. The Mobilize platform is an open platform that allows us to integrate other brand devices. So we're going to be showing you in this demonstration here how we can utilize other brand defibrillator analyzers to service the PM all through your mobile device, following exactly what the manufacturer requires. The PM will focus on the key points we just discussed, and we're going to go ahead and show you that PM process right now. We want to go ahead and get started on doing a service on this LifePak 20E. And really, before we connect anything up to the defibrillator, we want to make sure we do our physical inspection as required by the manufacturer. So they've stated to do a number of things. One of the most critical things, of course, is the visual inspection of the device itself. We really want to make sure we've done our physical inspection, looking for any damage to the device itself. Really important, could be an indication that there could be something wrong with the unit or it may not be functioning per the specifications. You want to shake it. They literally want you to shake the device, listening for any loose hardware. Any loose hardware inside the device, of course, can be a real hazard. So we want to make sure we've done that. And as we're connecting the cabling and the accessories to the defibrillator, we want to make sure we inspect it all, from the power cord to the quick combo cable here. We want to inspect it to the connectors, both on the defib side and on the cabling side, for all of the cabling, including the SpO2 and the ECG, to make sure we don't have any damage, particularly looking out for any frayed cabling, any exposed wires. We definitely want to make sure we've replaced and taken care of that. So can't emphasize enough the importance of the physical inspection. Once we feel confident we physically inspected it, everything looks like it's in the correct order, we want to go ahead and connect it up to our test equipment. In this case, we connected the defibrillator up to the electrical safety analyzer. Here on the left, we plugged it into it. We've connected the red, what we call red test lead cable, to the back of the defibrillator for important leakage testing we need to do. It's connected to the ground post on the back of the unit. Of course, we've powered up the safety analyzer as well. It's ready to go. We've also connected the SpO2 parameter, which this defibrillator has, to our SpO2 simulator here on the left. And we've also connected the quick combo cable up to our defib analyzer here, so we can do the important discharge shock test and the pacer test, as well as the ECG gain test on the device itself. We're also going to be utilizing our Mobilize app here, which will allow us to have a lot of confidence in how we're going to perform this test, because we're going to be able to actually see and run and execute the actual manufacturer's procedure step by step, including what are the pass-fail parameters, to give us confidence that we've done all of the testing and that it meets the manufacturer's requirements. So to do this, to utilize our app here, we want to go ahead and just kind of do a quick navigation of how the app works. And here on the home page, you'll see kind of the header information, which we can customize in the setup menu. To do this, you have the ability to enter an asset ID here. You have different modes you can use our app in. In this case, it is in checklist mode here, where I can see a library of procedures that I have kind of loaded on this device. And then, of course, we have here at the bottom the wireless Bluetooth devices we have connected to our Mobilize app. All works via low energy Bluetooth technology we call Mobilize. We've incorporated into our safety analyzer, our SimCube and MEP simulator, our OxSim, our FlowTrax infusion pump analyzer, which we're not going to use in this testing. And we've also incorporated other brand test equipment devices like the StageTrend Phase 3 defib, which is also connected as well. So to run this test, to get started, we want to go ahead and enter an asset ID. And if you have barcodes on your medical devices, the best thing to do is tap on the scan function. It will turn on the camera of your smart device, and I can go up to the barcode, scan it, and it will automatically open up the procedure that corresponds for this LifePak. And so here you can see I'm now viewing and able to run the manufacturer's procedure I need to perform the PM I need to do on this device. So at the top, it gives you just a little bit of demographic information about what test procedure we're going to run. There's the revision level of the service manual that it is based upon, and of course the test equipment that is needed to be able to run this procedure. So as a technician, we're going to go ahead and just follow this step by step. And I'm going to go ahead and say yes, I reviewed that step and it's correct. Now we're going to go ahead and do some basic things here. We need to capture some serial information serial number information and calibration date from our defib analyzer. And to communicate to our defib analyzer, I simply tap the run button. It does that, and it will request information we need, which is the serial number and its calibration date. That information is good. We've passed that test, and we go on to the next step. As we mentioned earlier, we want to make sure that we do that physical inspection. It's listed here as the next step in our procedure. If you're an experienced technician, you may already know exactly what all the steps are that are required. But if you're a new technician, then you may be unfamiliar or may be some time. And if you want to recall exactly what needs to be done, you can tap on this little eye symbol here, and it'll open up all of the exact steps from the service manual that we're required to do as part of this physical inspection. So you can see here it lists all of the important things, and it's really important to follow this because defibrillators are high acuity devices, the life support devices, and the wear and tear devices. So we want to make sure we've done a great job of doing this physical inspection. So that information is there for us. Next step here is to do a functional test for SpO2. This particular defib does have the SpO2 option. I need to confirm readings. I'm going to go ahead and run that test. In this case, we're going to go ahead and now utilize a Oxymplex SpO2 simulator for doing this testing. The manufacturer does allow us a quite wide range to do this test, but we want to use something precise to feel confident that our defibrillator is giving us good readings. So we can see here the target is 80. The measurement we're actually seeing on the defibrillator is 81. Allows me to tap on this field here, scroll and select 81 to capture that result based on what we've set it to, and we can complete that step, go on to the next one. Let's go ahead and do an ECG test. You can see here it wants to confirm, well, what kind of configuration do we have on this defibrillator for ECG? Are we using 3-lead ECG or not? In this case, we are, so we're going to select yes. And now it wants us to do a leads off detection test. So we're going to hit run. The defib analyzer now is going to be generating a sine wave, which will be picked up and transmitted through the ECG leads that are connected to the defibrillator. We can see the sine wave appearing here. And we're simply going to disconnect a lead from the defib analyzer to confirm it can detect the lead has been removed. And I want to do this for each and every lead. So I'm going to repeat that for the 2 leads, confirming that for each one, we're getting a leads off detection message. We can see that we are. So that test is good, it passes, go on to the next test. And then the next test is wanting us to do a gain test. We want to make sure that the ECG gain is correct as it's making sure that the amplitude is correct. We're going to go ahead and run that test. Again, the phase 3 is going to be generating a sine wave. My instructions here want me to go ahead and do this test on lead 1. I want to make sure that I'm in lead 1 here. We'll go ahead and change that. And I'm in lead 1. And I want to print out, we want to set the gain to ×4, so we're going to go ahead and do that. And then we're going to print out a strip and verify that the amplitude is within the range required. So I'm going to print out a quick strip here so you can see it. I'm going to stop that printer and go ahead and get that. And we can confirm here by reading the strip recorder that this strip is measuring between 25 and 31 millimeters as required per the procedure. I can see here it's measuring about 27. So this is within range, this passes. And I'm going to go through all of the required tests for the gain test to complete that. Proceed to do the shock test. We want to, again, just verify that we've connected our defibrillator to the quick combo cable to the defib analyzer. In our case, we're going to go ahead and do the quick combo cable test for the shock test to demonstrate that for you. Of course, we could do this by connecting the paddles up to the defib analyzer as well. We're going to start with quick combo cables. So in this case, if your facility doesn't happen to be utilizing the defib paddles, some do, some don't. We want to go ahead and decide if we're going to run that test. In our case, we're going to skip doing paddles test for this demonstration. The testing involves the same test. We're going to go ahead and skip the paddles test, and we're going to go ahead and proceed on to do the defib discharge or shock test using the quick combo cable. So I'm going to go ahead and select yes here. And as you can see here, now we can see all the steps required we need to do. So in this case, the next step, according to the LifePak 20 performance inspection procedure, is to run a synchronous cardioversion test. So we're going to go ahead and do that. And it's going to basically set the ECG to a particular shape. I want to go ahead and set the size back to normal, back to what it was before we did our gain tests. So we've done that. And we want to make sure that we can confirm that we are set for lead 2 and that we are verifying that our ECG waveform is correct. Then we want to press the sync button according to the information here on our procedure. It instructs us on what to do. We're going to press the sync button here and verify that we're able to detect the R wave here and display the arrow here, the green arrow above the R wave, to confirm that we're seeing the markers, the R wave markers appear on the ECG waveform, which we are. So we've passed this test and we go on. Next test we're going to do is the synchronous cardioversion test, verifying the R wave is synced within a particular time. We run that test. We're going to utilize the phase 3 defibrillator analyzer for this test. We're going to verify that the timing is within 1 to 60 milliseconds. This requires us to charge the defibrillator to 2 joules, and we're set to that. We're going to charge it. We're going to fire the defib. And we're going to verify that our defib analyzer sends us back a result within the right range. I'm going to go ahead and stop the printer. And we can verify that the defibrillator delivered an energy of 2 joules based on our setting, and that the delay for the R wave sync was 19 milliseconds, which is well within range of 1 to 60 milliseconds. That's a pass. The next test is we're going to do some discharge tests now, where we're going to verify the discharge values are within range. First test is 2 joules. We're going to run that. Again, charge up the defibrillator to 2 joules, which we set it for in the prior test. We're going to charge it. We're going to fire. And we're going to make sure that the result coming back from the defib analyzer is 2 joules, and it's exactly right on the mark. So we're going to go ahead and confirm that test as a pass. The next test is 70 joules. Let's run that test. I'm going to charge the defib to 70 joules this time. And we're going to go ahead and charge it. Fire it. Again, the defib analyzer is going to confirm that we got the energy at the right result. And this result was 69.2 on a target of 70, and our range is 59.5 to 70. You know that's a pass as well. So we're going to follow the last discharge test, which is 360 joules. Let's go ahead and run that. That means charging the defibrillator to 360 joules, which we've had it set up here. Let's charge it. Printer starts to print. We're going to verify that the result we get back from the analyzer is within range. And we can see here that on a target of 360, we receive the result back from the defib analyzer of 356.3. The range is well within range of that, 306 to 414. This is a pass. So now we want to make sure we do all of the remaining tests, including the quick combo charge time test. This is a time test to verify that the charge time of the defibrillator is within specifications. So it's a 1 to 10 second run test, and we're going to make sure that the defibrillator does that using a calibrated stopwatch. We're going to go ahead and start charging and start the stopwatch at the same time and verify how long does it take. It should occur within 10 seconds. Within 7 seconds. Go ahead and document that. Occur within 7 seconds. Let's go ahead and do that here. We've got the energy result, but this is a time test, so we'll go ahead and type in 7 seconds and make sure we capture it into our report. The next set of tests we need to run are the pacer tests. The very first thing we need to do before we get started is make sure that we've set the defib analyzer to the right impedance per the manufacturer's requirements. That's important to make sure our measurements are truly within the tolerance that are specified. In the case of the LifePak 20E, we need to set that impedance of the defib analyzer to 50 ohms. So let's go ahead and do that, and we can do that via the app here as well. So the app will communicate to the defib analyzer and instruct it to set its internal impedance for pacer testing to 50 ohms. So we've done that. We've made sure we've got our equipment set up properly. We can go on to the next thing. And the next test is we need to do a pacer leads off detection test. There are some things we need to do in the setup to make sure we have that configured properly. And one of the things we need to do is move the quick combo cable connections from the defibrillator input port, which is what we use to do discharge or shock testing, over to the pacer ports. So we would disconnect it from here, and I'll turn the analyzer around so you can kind of see it here, and we connect it to the ports that correspond to the pacer here on the left. So that allows us to be able to be ready to do the pacer testing. Part of this instruction is to make sure that we can detect a leads off condition for pacing before we do the test. So it's simply removing one of the ECG leads from the device, from the analyzer, and confirm we see the alert on the defib that the leads are off. So we can see that it's working properly to confirm that indeed it is detecting that. We'll do on the other lead to be sure. That's the second lead. And then the third lead also confirms that it detects pacer off. So important to make sure we do that. So we're good with this. We've passed this test. Now we need to go ahead and do a current test. So we're going to put it in pacer mode, and we're going to set it according to what is required here. In this case, we want to set it to 10 milliamps. So we're going to go ahead and adjust that current on the analyzer, on the defib. To do that, and we execute the test. In this case, we're waiting to do a measurement. So the Mobilize app has instructed the defib analyzer to take the measurement, samples it, and returns the result here. You can see here the measured current on a target of 10 milliamps is 11.1. We have 19.7 milliseconds, and the pulses per minute that we have programmed is 60, and we measured 59.7 and 118 microjoules measurement. So we want to make sure that we're within range. We need to make sure we're within 0 to 20 milliamps, and we clearly here are right real close to the target of 11.1. So we've passed this test. If at any time you need to redo the test, maybe you have a measurement close to the edge of the tolerance, maybe you simply made an error and set the incorrect current on the defib, you can simply press the retest button. The analyzer will repeat the test, collect a new result, and confirm that result. So you can easily repeat the test without having to go back and repeat the entire procedure. We've passed this, go on to the next measurement. The next measurement wants us to set it to 100 milliamps. Go ahead and do that here on the device. We've set that, let's run that test. Analyzer's going to sample it for a certain period of time, collect a stable sample, and then report back the results. Again, we have a result here of 101.2 milliamps, and that's within the target of 90 to 110. We've passed this test. On to the next one. One more, we'll do it at 200. It's important to make sure that these results are well within specifications, and if there's anything out or right on the edge, definitely important to repeat that testing a second time. So we have a target of 200, we have a result of 201.4, well within the range we have specified here. This test passes. The next test is we want to do a pulse width test. We want to make sure the pulse width of the pacing signal itself is within specification. We'll run that test. It's going to measure that pulse width in just a moment here and report back. So we left the current at 200 milliamps, but our pulse width should be between 19 and 21 milliseconds. And you can see here it is 20.26 within range. That is a pass. The next thing we want to do is we want to do a patient impedance test. And for this test, it's really taking a decade box, a resistance box. You connect it up to the ECG leads to confirm what resistance does the medical device detect a leads off condition. So in this particular case, they want you to use a high power resistance box, which is specified in the service manual. We'll show you the model number here in a moment. And you can purchase that and use that to do this leads off test, to do that basic resistance test to confirm at what impedance does it detect the leads off and a no leads off message. So we've done this prior, so we're going to go ahead and save time, go on to the next test. Now, we want to go ahead and get the device ready to do the electrical safety tests. Electrical safety tests are important. We need to make sure we do those. Depending on what your protocols are for your facility, you can do it a number of different ways. We're going to go ahead and turn pacer off since we're not doing pacing any longer. We're going to do the electrical safety tests. So we need to follow the instructions that are laid out in the procedure. In this case, we want to connect the red test lead cable from the safety analyzer to the defibrillator ground post, which we've done. Now we need to move the ECG cabling from the defibrillator analyzer over to our safety analyzer. So let's go ahead and connect that up because we're going to do a leads leakage test here. We're going to verify that the results are within the proper specification. So bear with me just a moment here. Got it connected. We want to get ready to do an electrical safety test. We'll go into the safety test mode to get ready to do that. We've connected the power cord to the safety analyzer, and we've set up this test according to this procedure here so we can get started. So in the manufacturer's procedure, it requires us to do the electrical safety testing according to the ISC 62353 standard. So we're going to go ahead and follow what that standard requires. Of course, what standard you follow could vary depending on your company organization's protocols. Some customers follow NFPA protocols, which are common, or you can follow exactly what the manufacturer requires per the manual, which is what we're going to do here. So in this case, we're going to be doing a number of different tests simultaneously. We're going to do the protective earth resistance test, a direct applied parts leakage test, and we're also going to do an earth leakage test, all automated using the safety analyzer. So we simply tap on the run button here, and the mobilized app will instruct the safety analyzer, as you can see here, to go ahead and begin to do those series of tests. So it's already programmed to know what tests we need to do. It knows the standards limits for the 62353 and what are the pass-fail limits we need to make sure we comply to. So it's going to go ahead and execute those required tests. And you can see when it's doing the leakage test, you could see some noise here. That's normal because we're doing a main unapplied parts test where we're taking AC voltage and we're actually applying it to the leads to measure leakage. So it's normally you see some noise on the ECG signal as well. You can see here on our app, it's performing the test. It's telling you the test that's being performed, the measured leakage, and how much current the device under test is drawing. So we're not drawing too much current here. So it's going to go ahead and do that, and it's going to complete the test. It's going to go back and automatically post whether all of those tests passed or failed, and record the date and time we did those tests. Now we need to make sure we go on to the next step. In this particular app, for this defib, there are a series of different electrical safety tests we need to do. So we need to just keep following the instructions. So the next step we want to do is move the banana plug side of the red testing cable over to any of the other ECG snaps that are available. So we're going to connect it over here. The analyzer has a banana plug interface, so it allows me to slide that banana plug right underneath that test lead to do that particular test. We also are going to connect the SPO2 test lead cable. It's an adapter available from the manufacturer that allows me to connect my SPO2 over to my safety analyzer so we can do a lead leakage test on this applied part. So anything that can come in touch with the patient is considered an applied part. We need to do a safety leakage test on it as well. So we've connected the SPO2 adapter cable from the defib over to this banana plug connector that we can now connect over to the safety analyzer. So that's the second thing we've done. And then we also need to connect the quick combo cable because we need to do a leakage test on this as well because that comes in contact with the patient. Also connect that to the defib analyzer. I'm sorry, to the safety analyzer. So we're going to remove it from the actual defib analyzer. And we're going to also connect it over to our safety analyzer. Just slide it underneath one of these plugs like you're seeing here. So we're going to do that. So now we've secured all of our leads and the device so we can perform this next test. So we've got everything set up properly and we've got that set up complete. And now we're going to run the second electrical safety test according to ISC 62353 standards, which is the direct equipment leakage test. So we'll go ahead and run that. And again, the procedure in the Mobilize app knows exactly what tests need to be performed. You'll see it here at the top again. Go ahead and do that leakage measurement. how we have the device configured to perform the direct equipment leakage test. And then it's going to, again, show you the current being drawn by the device under test. So it's going to run through all those tests we need to do. And I've confirmed that all of the tests passed or failed. Any tests failed, it would say fail here, but they all passed. And so now we've completed the second test. We have one more electrical safety test to do, which involves changing the setup. So we need to simply move this banana plug from the red test feed jack back to its original position. I'll go ahead and do that here. And now we're ready to do the next test. The last test is to do what's called the direct applied parts leakage test for the therapy and the direct applied parts test for the SpO2. So the therapy cable is considered to be this quick combo cable. And of course, we want to do a leakage test on this SpO2 port. Per the manufacturer's recommendation for this adapter cable they require to use, you'll find the part number in the service manual. We'll post it here as well in our video for you. And so we've got the test leakage for these things as well. So we've got that electrical safety analyzer configured to do this test, and we're going to run that next test. So again, the procedure knows exactly what tests need to perform. You as a technician will just press the run button and will automatically perform those tests and verify that the results are within the specified limits from the service manual for the light pack. We've completed all of these tests, and now we're done. We've completed the entire procedure involved based on the manufacturer's requirements for testing the LifePak 20E, and we can go ahead and say we've completed this procedure. We press yes. Now the app will take you to a summary page where you can see the entire electronic report for everything we just did to service this LifePak. Okay, so we've completed the PM on the LifePak. Just to quickly summarize what we have as the end result is we have a complete electronic report that has everything that we did as we saw in the demonstration, including all the parameters, all the testing we did, and you can add additional notes if you needed to document additional things that you noticed when you're doing the PM. You could actually use the app to take images and add those to the report as well. Maybe any physical damage or anything you want to make a note of, you can go ahead and add that in there. And of course, the report has the ability to be exported in a variety of ways, including integrating it into a CMS. So you can see the report has your header information in there. It lists all of the test equipment that was utilized to do this PM. So not only what model, what serial number, but the calibration date of the test equipment. So the test equipment knows its calibration date and electronically via Bluetooth sends it over and adds it to the report. This gives us real confidence in the report we've just generated, meets our requirements, and for auditing purposes, DMV or Joint Commission loves to see that information on service reports so that we're confident all the work was done according to our protocols. And of course, below that, you have all of the data that corresponds to what we just tested. This is just a sample of the data. Of course, we ran through more steps, but just to give you an example of what kind of information gets loaded onto the report. You have measured values, you have tolerances, and you have every step involved with that procedure we just ran. So all this is done via the Mobilize app. The app, of course, stores up to 1,000 records. That allows you to keep them on the app and transfer them at any time to whatever system method you want to upload that information to another database or to your CMS. Of course, when we finish the PM, the last thing we need to do is attach a PM sticker. And one other option just to mention is if you needed to, PM stickers can be kind of a cumbersome thing depending on your organization and how they manage that. So part of the Mobilize app, we've added a Bluetooth commercially available printer that you can pair to the app. We work with the company, it's a brother printer. We work with the company to develop a custom driver that allows it to automatically communicate to our app so that you can create a customized PM sticker and attach it to the medical device. So you could define the fields you want to have on the PM label. You could decide what fields you want to have enabled or not. You could even pick the PM interval for the next cal date. It's available multiple colors, and it's also battery operated. So that's our presentation. Does anyone have any questions?
Thank you much. We have got some here, Julio. The first one is, what standard should I be using when performing the electrical safety tests on defibs?
Yes, that is a common question we get, not only for defibrillators, but for other medical devices. And it really comes down to what your organization, so your hospital, your independent service organization's procedures say. We always want to do whatever our quality system states for us to do. If your quality system states you're going to do exactly what the manufacturer requires, then we need to follow exactly what the service manual says. If your company's organization has different protocols, then those should be identified, communicated, and you should follow whatever those safety testing protocols are. But you can't go wrong following the manufacturer's requirements, so that's always a safe bet.
Okay, so what about my current PM procedure doesn't require me to perform any leads testing for leakage. Is that something we should be doing?
Yeah, leads. Leads, of course, is anything that comes in contact with the patient. Could be a patient safety issue. As a general rule, anything that comes in contact with the patient, it is highly recommended you do a PM on. Of course, if your organization has made a conscious decision not to do that, that could be acceptable. Just make sure you have it documented as part of an AEM program, maybe an alternate equipment maintenance program that specifies that you're not required to do it and your justification for not doing it. But generally speaking, you definitely want to try to do testing, leakage testing on anything that comes in contact with the patient.
Okay, and I've got a question about the app here. Do you have any other procedures that can be run on the Mobilize app?
Yes. So we've developed a wide range of procedures based on manufacturers' service manuals on a wide range of equipment, be it infusion devices, patient monitors, other devices that maybe don't have a specified piece of test equipment. So we're making OEM level procedures that can be run on our Mobilize app.
Okay, we got time for one more question. This is also about the app. It's where is it? It was, when do you think the Mobilize app will be available for Android?
Android, yes. Our app right now, we released it for Apple iOS. It's the most common platform used in healthcare for security purposes. We do know there's Android users out there, very, very popular group. We are working on an Android version. We've been focusing on finalizing the features in the Apple iOS version that we're seeing here. We're continuing to add more features, but we're also now starting to work on the Android version we hope to have available, towards the end of this year.
That's great. Well, we're coming up to the end of our hour, Julio, but I've had lots and lots of questions come in. So what I'm going to do, I'm going to forward you all the questions once we've finished here. And to the attendees that have submitted the questions, Julio and his team will reach out to you with the answers. So please be patient. They will be in contact with you. So once again, Julio, thank you so much for your time and for a really great and informative presentation. I'd like to encourage everyone to visit today's sponsor to learn more about the product they provide to our industry. So visit prontech.com. And as promised, the answer to today's trivia question was Arizona. And of course, the Super Bowl will be played in Glendale in Arizona. So congratulations to our winner, David Messer. Just a quick reminder, you can obtain your certificate by completing the post-webinar survey, which will be emailed 1 hour after we finish the completion of today's webinar. You must complete the survey to receive your 1 CE credit from the ACI, and you'll be able to download the certificate directly from your computer once you've submitted the survey. If you have any questions, you can reach us at webinar@mdpublishing.com. We'll be back next week with another webinar, so please visit webinarwednesday.live for more details and complimentary registration. Thank you once again for your time today. Enjoy watching the Super Bowl on Sunday and good luck to both teams. Thank you and enjoy the rest of your day.